So this is a Frankenstein of a talk. So I put together bits of pieces of different talks I made during the last 1.5 years. So it's basically, you could say, it's a summarize of some of the things that I learned while being at Lunar. Hello. I've been at Lunar for 1.8 years, and this week is actually my last at Lunar. I'm getting a new job. So yeah. I'm starting at Velux to help with platform engineering. So yeah. Yes. And so that's also why some of these slides might not look like they belong, stylish wise, because they're taking out of different talks. So just so you know. But there were some things that I really wanted to share as a coherent story, and that's what I try to do here. Yes. So a bit about me. Here's a picture, so you know what I look like. So you can find me. I'm an organizer in the Cloud Native Aarhus group. I occasionally speak at meetups, conferences. I've spoken in Berlin at KubeCon, and I've spoken in Valencia at KubeCon as well. I was lucky enough to do a keynote, which was really awesome. Slightly bigger crowd, but basically the same thing. I have a hobby. I have a new hobby because I have kids. The old one took too much space, apparently. Right now, I play Dungeons and Dragons with my family, and I paint small plastic stuff that we then use and pretend to be alive. Yeah, so I'm a grown-up. And another thing me and a colleague is trying to do is we're trying to do these platform engineering courses. So GoTo reached out and asked if we could do a training session, and we said yes. So we're doing a platform engineering fundamentals and advanced at GoTo in Aarhus, if there's not enough people who wants it, of course. So if that's your thing, then yeah. Yes, so here's a slide of the Cloud Native Nordics. So here you can see where we actually have meetup groups. I don't know if it's up to date. No, it's not. But it's somewhere in the middle. Yes, so yeah, so what did I learn at Lunar? One of the things I noticed when I started there was the speed. So we have 150 releases in dev per day and 39 in production per day. I think the last time I looked, it was about 230 in production per week. And we have what, 160 developers, I think. 120, 60 sounds better. 100 and something. So it's a lot of speed. I mean, from idea to production. So from you have an idea of, hey, I need to create a new microservice to it's running in production, takes 5 to 6 minutes, basically. So that's nice. Then I tried to learn some of the stuff they do to achieve this. And that's what I'll go through today. Yes, roughly 5 minutes. So first off, we need to know who this guy is. This is Melvin Conway, and you probably heard of Conway's Law. How many of you have heard of Conway's Law? Wow, that's a lot of people. Awesome. So he basically said that the way you organize people, or the way the information structure of an organization can be seen or traced in the software they built. So a funny example was many years ago that 8 people was commissioned to produce a Cobalt and Algo compiler. 5 people were assigned to the Cobalt and 3 to the Algo, and 1 ran in 5 phases and 1 in 3 phases. So there's a lot of things where the thing we do in the software domain and how we interact in the people domain, there's a connection there that is really hard to not have, right? So you actually pay a penalty if you try to break it. So with that in mind, let's move on. Mark Burgess is the next guy I encountered, not in Lunar, but on the big internet. And we don't really talk about promise theory in Lunar, but I think we sometimes mention it, and I can see promise theory in a lot of the stuff we do. So I wanted to explain what promise theory is. And yes, it's HTTP. He doesn't have S. So he's super professional. But he's a scientist. I think he's a physicist. And he developed this promise theory. He developed one of the first configuration management systems in the world before Puppet and all that stuff. And Kubernetes is based on promise theory. So if you've seen the documentary, Kelsey Hightower says this. So it's true. Yes. Hashtag my hero. So promise theory, what is that? Well, it's about controlling variations, basically, or uncertainty. So this is a cake, I guess. So if you follow a recipe, you sometimes notice that you didn't get the result on the box. Maybe you have a different oven, maybe a bad example for this cake, but maybe you have a different environment, humidity, temperature, and so on, and that will affect the result, right? And you see it every day when you see everyday bagdysten, how it messes up everything because it's in a tent, it's different machines, they have to adapt, right? So promise theory is trying to flip that around. So it's about obligations versus promises. So an obligation is if I tell you, I want you to bake this cake for me, but I want you to do it in this way. Use these machines in this room, do it in this order, precisely follow this. That's an obligation. You need to do as I say, right? The problem with this is if things change, let's say the humidity or the temperature or whatever changes, you're in problem, right? Because you cannot make the cake. It'll not be as I said. And the only one who can't fix the problem is you without breaking my or your obligation to me. Whereas a promise is turning it around. If you go to a bakery and say, I want a hindbærsnitte, and I want you to use økologisk flour or whatever, and Læsø from salt, no salt from Læsø, I guess, they're going to laugh at you and say, no way you're going to decide that. That's not up to you. You can give me money and I'll give you a hindbærsnitte, right? So what the bakery has is they have a promise. If you give me money, I'll give you a cake. How it's implemented behind the curtains is not up to you. It's not something you get to decide, because if things change, if they run out of the flour that they used to use, they can buy something else without breaking any promises to you, because they can still deliver a hindbærsnitte, right? So it's the same talk if we talk about teams, autonomous teams, right? So the further out to teams you can delay decisions, the better, because they can adapt faster, right? So the thing in promise theory is that he goes all crazy and he has notations and all sorts of stuff, so you can actually test your system if it's a stable system or not. So here you have a sender and a receiver. So this could be the baker and you, and the sender gives money and the receiver takes the money. That's a transaction. And it's zeros to sum, or sums to zero, sorry. So it's a stable system. Now, after this, there's another exchange where it's flipped, right? The baker gives you a cake, you accept it. So still zero, it's still a stable system. So if we do something like this, where a sender makes a promise to a receiver, and that receiver makes a promise to another one, and that one then accepts the promise, then it's not that stable. Because if something breaks in this chain, the sender doesn't really know where, right? it doesn't sum to 0. So it's a way you can assess systems to see if they're stable. We don't use this at Lunar, but the way of thinking, I see that in everything we do, basically. So here you have another pattern, a stable pattern. So you have a sender and 2 receivers. The 2 receivers don't know if they agree, but they might not need to. This could be a leader setup. It could be a broker set up with a queue and microservices in a software domain, right? So this is what promise theory is about. Having your promises on the outside and the implementation on the inside, hiding it. It belongs and is owned by the ones implementing it. And then you can scale it. So you can have, so the simple receivers and senders are called agents. And then you can group them in these super agents. So in people terms, it could be people and teams. In software, it could be microservices and bounded contexts, right? So you can use it on different things. And again, on a team, you make your promises on the outside. This is what we can deliver. This is our promises. We can make you a promise that we can run your container. We can make a promise that it's compliant. You don't need to know how, and you cannot tell us how, because the ones who know best is us. We're the ones doing it. The baker knows best. Okay? Any questions to promise theory? This is like a quick overview. So he doesn't define a super agent, but I guess you can have as many as you want. But so the for instance, the leader setup, he says, is a great way to minimize the load on the system. The more promises you need, the more complex it is. So if they don't need to know the 2 receivers, if they align, then this is a great pattern to reduce the amount of connections. Right? Yeah. Then there's something called team topology. How many of you know what that is? Less? Wow. I wouldn't have thought that. Okay. So these 2 guys made this way of organizing teams, people, called Team Topology. They have a website with an S, so they're pros. That's nice. And they have these components or types of teams and interaction modes. That's basically what they define in promise theory. So you can have different types of teams. You can have stream-aligned teams. They're end-to-end teams, so developers that deliver value to customers. They should be autonomous. They should not depend on other teams. They should be able to deliver. Then you have enabling teams. You can think of these as internal consultants, so people who help in things that are complicated. So it could be security, it could be a QA, it could be legal, it could be whatever. So they are not part of a team, but they will assist the team and help them out. Then there's complicated subsystems. So these are teams that build stuff the other teams can use with an API to make things easier for them. And in a bank, there are 1 or 2 complicated things I can say. So you build stuff that make it life even easier for the stream-aligned teams. And then we have the platform team at the bottom. That's the part I'm part of in Lunar, the platform colony, we call it. We don't have dinosaurs, but we have colonies. And this is the team that builds the platform. And it's a different way of thinking about things. I've seen numerous talks about developer experience and platform engineering. And what they're doing is they're just giving developers more tools to do things. And that's not what we try to do, at least. We try to make life easier for developers. So what we do is we abstract things away. Then we have the interaction modes. You can either be collaboration, So you work together on something and develop something. So that could be a complicated subsystem cooperating with the streamline teams on making a central component, and then they can use it over an API. It can also be X as a service. So the platform is X as a service. So there's this thing, what would Amazon do, right? So if your platform team says you need to create a ticket, and then some dude will create a VM in 3 weeks' time, Amazon wouldn't do that. If they did, they wouldn't be in business, right? So everything as a service, automated, fast, right? At Lunar, we could, I would say, basically take Kubernetes out and put in Nomad if we wanted to, and the developers would most likely not notice. But I'll get back to what our developers do. Then we have facilitating mode. So this is where they help out. So this is the enabling team. So it could be legal, it could be QA or whatever. They will go in and help a team to get better at something or understand something, help them out, and then go back again, right? Are there any questions to this? Or are you all certified now? Awesome. I need to print a lot of certificates. So this is what it looks like from the Team Topology side. We have the platform at the bottom, everything as a service, streamlined teams, complicated subsystem that collaborates with another streamlined team. It's as a service to the first streamlined team as well, because it's finished what they have done. And then we have the enabling team that collaborates or facilitates something for the team. Yes.
What does that make sense that platform teams to interact a lot with the enabling team?
Yeah, so there's a difference between, you could say, so we want to learn a lot about our customers from the platform. Our customers are the developers, right? So we attend platform guilds and all the stuff where we can get in and listen and ask questions and learn about what they do, what the pain is. But this is more like the running software, basically. So when you need a VM or a container running, it should be as a service. You don't need to go into Jira, hopefully not, and wait for it, right? I've been to companies where they had to wait, like, was it 4 or 5 months for a VM? So they would always order 2 extra. And it became a currency in the company where they would whisper, do you have any VMs? I don't know, what do you have, right? And it's really weird, right? So here, imagine it's AWS. That's a good standard to thrive for, right? Yes. So I just rearranged it and lost some of the information, but this is my drawing of it. Everything as a service, This is when it's up and running, right? We have the streamlined teams. The reason why I do this is later on, I'll get back to this and I'll add some stuff. The platform. This is what we imagine, right? Awesome platform. And I'm part of the platform team and we're in cloud native community, and that's where our interest is, I guess. Right? So abstractions, we do them all the time, hopefully. Developers do it. They make interfaces. It hides away complexity, right? So if you do a, what's it called? Get in English. Pictionary, thank you. You would probably try and optimize for this, right? Why wouldn't you go all the way over there? It's way too expensive in time, right? You'll never get to even draw the beard or whatever. But if you're at the police station and they ask, what did he look like? This is probably a bad place to start. You'll probably want to go over there, right? So depending on the situation, you want more or less details. So we can ask ourselves, how many details do our developers need to know to run their code? They're just focused on running their code, solving a problem, delivering value. Maybe they don't care about CIDR ranges. Maybe they don't care about containers, Docker files, Kubernetes manifests. Why on earth should they do that? Right? It's just a waste of time. Let's go over here. But if we want to be compliant and be able to prove what is running, we might want to go over there. Right? So in Lunar, we do both, basically. Oh, yes. So again, our developers, they like to code, make decisions, and release. That's what they get out of bed for. And they're good at it. Not these things, not getting out of bed. They really don't want to talk about infrastructure or Docker files, manifest, and like me, Terraform. They don't want to talk about creating databases and access control and stuff like that. They just expect it to be there, right? And that's what we try to help them with in the platform team. So in Lunar, they created 2 tools, well, more, but these are the 2 essential that the developers sees. So one of them is Shuttle, the CLI. It's open source. And the developers use the CLI. And with that CLI, they can go into any repository and run shuttle commands. They can build the repository, whatever it is, Go, Java, doesn't care. Shuttle run, build. All you need to know. Shuttle run, test. All you need to know. And it'll do it. Because behind the curtain, we have abstracted away templating. They don't need to think about Kubernetes manifests. They have a shuttle YAML file where they define what is important to them, the left side of the abstraction thing. And we translate it to the other side, right? We fill out the gaps. So scripting, like build, test, and so on. The pipeline, we have a pipeline in Jenkins. All it does, almost, is shuttle run something. So everything you can do on your laptop in a repository, Jenkins just does the same thing. Right? So it's much more simple. We don't have this huge shared library in Jenkins. Security also abstracted away. They don't need to know how, they just need the information when something is wrong, right? And compliance and so on. Then the other thing that was developed is the release manager. And they have a CLI called Ham CTL. Ham was the name of the first chimpanzee in space. It's not the meat. And that's the other tool they do. So they use it to release software because we use GitOps. If you use GitOps, your pipeline should not deploy, in my opinion. It should create the artifacts, put it somewhere, and then releasing should be a business decision. In this case, we use HAM-CTL. It abstracts away release. It's used in CI to communicate back in Slack to the developers. That's why I said it's not shuttle, all of it. Ham is one of the, or release manager is some of it. GitOps, it moves things away. So it does the actual release of copying the release to the GitOps repo. It gives you a status. So you can say ham-ctl status in any repo, and you will get a list of what is running of this component in all environments. You get feedback in Slack, and you can roll back if something goes wrong. It's also open source. Release manager has 4 sides of it. So there's the actual release manager that the CLI talks to. There's the CLI. There's a CLI called Artifact that does the Slack notification. And then there's the release daemon running in each cluster that knows exactly what is running. Yes.
More question about shortcuts. It looks super good, of course. And
Yes.
and I also love the idea you say hide the complexity away from developer.
Yes.
So my question is, there's something developer has to know in order to run containers, like the scaling. You scale to 3, 5, 10 replicas. Then certainly, for example, if you have an in-memory database where you need to read the state, temporary state, something like that. If developer doesn't know that the code will scale to multiple instances, You probably will not think that I need to keep this somewhere or replicate somewhere that every replicas can access.
Yeah.
How do you solve that kind of issue?
So when we abstract it away, they can always opt out. The great thing about shuttle, I think you can think of as a merge of Helm and Make. Right? Is that fair to say? It can do those two things. It can do the templating thing, and it can do the Make thing. Now, what they can do is they can opt out on one simple thing, like the ingress. They can opt out on that by copying it from the plan that we use into their repo, and it'll use that instead. It'll overload it. They can also, in their shuttle file, say, I want 5 replicas, and thereby overloading or overriding the default 3 that we have. So we don't want to make all the decisions and not making them able to bypass it. We want them to be able to, opt out. Yep. I don't think not concrete numbers, but I think it's fairly few people who opt out. And those who do, so when we moved to the newest Kubernetes version, there was something about ingress that needed to, and then they learned what. So you can opt out, but you get the responsibility, right? So with great powers comes something. Yeah, yeah. Oh.
All right. So what about if audit and those people show up, security guys? Is it one developer who can push all the way with hand control, or is it multiple developers, or there's some sort of multiple responsibility here?
Do you work in a bank?
I work in a dinosaur. Well, not a bank, but a pension company.
Okay, because that's the question we get from other banks. So we have peer review or 4i principle. So in order to, get your branch merged into main, you need another developer to be accountable. When you have a branch, you can actually release it to a test environment, just like that. You can also say auto release a policy in ham so that whenever I create a branch or push to it, I think when you push to it, yeah, it will actually automatically release to dev. And some even have auto release when merging to main, then it'll just go to production. So we do microservices, small changes, so they feel comfortable with it.
But it's all handled by review of the code, peer review of
Yes.
check-in. Cool.
Compliance, yeah. So this is what you get in Slack from the artifact CLI that I was talking about. So you can see it, and it progresses, so you can see exactly what's happening and when. That's nice. We also use Backstage where we scrape all the repositories. And because every repository defines owner and domain and so on in a shuttle file, in every repo, we can scrape those and we can build up a graph of ownership. So here we have the Empower colony or afdeling. We have the Squad Odyssey, that's us. And these are all the things we own. So and that's just get updated automatically all the time. So that's nice. Yes, software dependencies become team dependencies and can only be solved in the software domain. So this was one night when I couldn't sleep. I came up with that. And because now we have teams that have specific functions or say responsibility and a way to communicate, but we still get dependencies, and dependencies kills everything. That is the biggest problem. How many of you have worked or work at a company where they use SAFe? I'm sorry, first off. In SAFe, they have something called a program board where they map dependencies. I have a picture later on. It kills every flow, right? And I think most people agree. So we cannot organize us out of this. So every time you see a transformation, they shuffle people around and say, hey, we solved it. But you can't. You really can't. So we need to solve that. So how does Lunar do that? Well, we do it differently because we don't want this, right? And this is from a movie, so it's not real, just to be clear. Ethics slides, hashtag. Yes. So Eric Evans came up with domain-driven design. And I think if you work at Saxo, you have probably learned it from one of your architects. What's his name? Who couldn't be here today? Simon, because he has something similar. It's called something else, something with castles. Can't remember the name, but it's basically the same thing, I think. But domain-driven design is what we use to architect the domain in our software. So, oh, it's animated. So physically, we have a microservice, right? It's in a repository. You can go to Backstage, you can query it, you can see who owns it, what domain, and so on it's part of. Then there are bounded contexts. So these are logical boundaries where we say, you are not allowed from the outside to depend on this or to push something into this or decide anything. So if we go back to promise theory, a bounded context is your, super agent, right? And inside the super agent, you have services. And the bounded context create promises on the outside, right? So one service could be, hey, I create new users and I'm really good at it. Could be another user in another bounded context saying, I need to send an email to new users. So it needs to know that. So how do we resolve that dependency as well, right? Because that's a different kind of dependency. But I'll get back to that. And then on top of these, so yeah, they get assigned to teams. So each team has one or more bounded contexts. Because now we know that a bounded context can work independently of other bounded contexts. And because of that, our stream-aligned teams can do the same, because we don't have the software dependencies. We try to isolate them. And then on top of that, we have, subdomains. So it's domain driven, and then the subdomain, right? So, and on the people side, we have the colonies. So you can see we have Empower. Is there a laser here? Oh, this is cool. This is the department that I'm part of, right? The platform team. And then on the top, we have the Lunar domain. So this is banking, basically, right? So we break it up in chunks that are independently to each other. Then there's, of course, still the start-stop dependency that I need to send an email. So how do we do that? Yeah, so this is what a bounded context is. This is something from event storming, which is something you do with in domain-driven design, where you build up understanding and the language about a small part of the system, and then isolate it. Right? Yes. So if we put these into these stream-aligned team boxes, that means that these teams are independently from the platform, because that's as a service, and from other complicated subsystems, things they need to use in order to do their thing. It could be a transaction or something like that. But now they're also independently from each other, because these are self-containing containers, right? They don't have dependencies. They can work independently because they're made to do that in the software architecture. So what happens now that users created, I need to send an email and I need to prepare an account. Let's say these are 3 services running in 3 different bounded contexts for some reason, right? So the problem is, if I have the responsibility, I have the obligation as the user created microservice to tell the 2 others, right? So if that one doesn't answer, it's my problem. what do I do? I can retry a lot. That's not really what we want, right? Because this is a dependency again. What we do instead, we use a queue, we use event-driven. So what we do is I say, I created a user, and I'll publish an event, and I'm done. From here on, it's not my responsibility anymore. I'm done with a done. Then whoever needs to know when this occurs will subscribe to this channel, this queue. And they will then act. Whenever this last service comes up and running again, it'll get the message and do what it needs to do. So we flip the dependency in this way. So to summarize, we don't have people organized in function, dev, test, security, operations. You have a handover and you have dependencies. We don't organize software in a way that it's distributed across teams with dependencies, and we cannot do this before you've done that. We solve that with domain-driven design. We don't have the start-stop things. I cannot release this because you're not running, and what do I do when I run and you don't? We solve that with a queue. So those are the things we do in Lunar to get the speed that we have. So we do this in order to not have this. Yes? Oh, okay, thank God. Oh.
You talk about the speed and that you don't have dependencies in this case, right? But I imagine you have some schema validation between. I don't know which event broker. I can guess what kind of queues you maybe use. So what happens if the contract is broken between the producers and the consumers? Like, it's still kind of a dependency, right?
Yes.
How do you deal with that?
So it's a contract, and the broker we use might be inspired by a bunny kind of creature. But yes, so the contract is what's important now. So as long as you uphold the contract, things should work, and we trust the contract. Now, I'm not an expert in the software deeper details. I don't know if you know more. No. But it's rare that they actually need to coordinate. There are sometimes, but it's really rare. Not like this. Right. So here's a program board from SAFe where you have iterations. Each iteration is, I think it's 2 weeks, a sprint, if I remember correctly. And these can't deliver before these have delivered, before these has delivered. So you get small waterfalls. And this is a pretty picture because in the real world it looks like this. Can look like this. And this is what we fight really hard to avoid, because this will break or stop flow, right? Hello. And I worked at companies where they had these. I mean, we used Miro, and you couldn't see the table for strings, right? So every team needs to be able to deploy, release independently of others. Because I can release the send email service before the user creator service is ready. I just won't get any messages. But I can release it and I can test it. And I can be done. I'm not depending on them. Yeah. Hopefully no questions to this. This is bad. So, yeah, any questions with us? Cool spaceman? Yes? Oh, well, we need a microphone because we have digital people.
Maybe how do human bias and politics influence your theory here?
How does?
Yeah, politics in an organization, human bias as behavior. I mean, in theory, it sounds great, but it's in reality you can have behaviors, politics which are influencing and maybe distorting the the structure, the intention. I mean, I'm just asking from real life, well, how is it working without any problems or?
So I think my opinion is that I mean, I made some fun of SAFE today. I don't think it's necessarily a bad thing depending on your maturity. I'm not saying people should do this and go home and then just scrap everything and do this. There's something called survival bias. How many of you know what that is? Some. So during World War II, the British would investigate the planes that got home for bullet holes, and they would reinforce planes where the holes were. That's really clever. That just didn't help because those who came back were the ones who weren't hit where they would, go down. They would actually need to reinforce them where there wasn't any bullet holes, right? So you should be careful to optimize for the survivor, the obvious thing, DORA metrics. I like DORA metrics. They're all about speed, but you shouldn't sacrifice everything for speed, right? There might be other things that they did that gave them the speed, right? So yeah, does that, I mean, yes, we have politics, we have had cultural clashes, but I think most people all the people I met in Lunar are very technical, skilled people, and they value the technical things higher than opinions, mostly. Yes. Other questions?
Also nothing from the slider. Everybody there to speak up today.
Yes.
Amazing.
Hello. I'll ask a slightly off-topic question then. So Shuttle and HamCTL are open source.
Yes.
Could you tell us a bit about the experience of open sourcing your internal tools?
Yes. So you're asking about how often do we check for pull requests and stuff like that?
I think more, what was maybe let's say what was the biggest benefit of open sourcing and what was the biggest challenge?
I didn't create any of these. Maybe Casper can say more, but I know you had a pull request for Shuttle that we didn't attend to.
Also that. No, but in all seriousness, I'm currently consulting at TV2, and they have just this week open sourced their new gateway controller. And we're having a lot of talks internally about how to handle open sourcing things, like where should we put our efforts? Should we put a lot of effort into the open source part? Should we not put a lot of efforts into it? How much responsibility do we have towards the community? Things like that.
Is it on?
Yeah.
Yeah, so I can maybe talk a little bit about that because I was part of open sourcing Shuttle and I wouldn't say we are fully open sourced the release manager project. It's publicly available as we define it because it still has some Lunar specific stuff in it, but we actually did it a lot in order to talk about what we were doing. We wanted to use open source Shuttle as an open source project and really try to make it independent of Lunar specific stuff. I think we come to a point where we sort of made that, but Shuttle is also pretty simple in its nature because it's basically just a templating engine and it can execute scripts as it is right now. That's more or less what it does, but it's really powerful in the abstraction that it creates. But I think from sort of the company perspective, it was more we want to do some open stuff. We want to give something back to the community. We are using a lot of technology open sourced from the community, and we want to just give back to whatever we are doing. So it's more like here it is, take it, and we didn't really have like a really big strategy behind it. And we haven't really had any major pull requests come in, maybe that one, but it's not been like a huge success or massive adoption of everything like that. It was more for visibility basically and getting some feedback on and a way to talk about what we were doing. I see stuff going on. I hope that answers the question.
Any other questions?
What's the difference between shuttle and scaffold?
Scaffold. I don't know scaffold.
Made version.
So I can maybe answer. I'm not sure. I haven't tried out scaffold either. But so we were pretty early on creating shuttle back in 2018, I think. Back then there was Helm to do charting and stuff like that and templating. And Helm came with this awesome component called Tiller, right? If you're, which wasn't really a good thing in terms of being a bank. We didn't want that stuff running, so we wanted to create something ourselves, and that's basically why we created Shuttle back then, because there weren't anything out there. And also, when we adopted GitOps in 2019, the only thing that was around back then was Flux, and I think we're doing some Weave Cloud stuff in order to move things between different environments, but it wasn't really what we wanted. So we built everything ourselves instead to tailor it to the workflow that we were sort of seeing make sense. We talked to all our developers, asking them for feedback on how should a flow look like. Get all that input, and basically in this period we were also getting a banking license and becoming a bank. So how could we merge this with all these compliance requirements? How could we create this flow where we still had these 4 eyes, follow the 4 eyes principle, getting approvals on all PRs. So we needed to integrate that into the release manager project as well. So that's why we basically built everything ourselves. So yeah, it's sort of a, we were pretty early on adopting these things, and then we had to build stuff ourselves. And then something were changed on the way, but I think you did some Helm stuff at some point, but
yes. So I actually hid Helm behind Shuttle. So you can simply in your Shuttle file define this is the Helm chart, this is the version, and then the rest as normal. And then it'll actually just take the Helm chart and then run Helm template. So we template the value file based on the Shuttle file, and then generate the manifest file and put that as a release. The thing I didn't mention about Shuttle was that the great thing about it is all this scripting and templating you can put in another repository and then inherit it. So you can use it for multiple repos. So all of our Go microservices, they use the Go plan. So we just need to change one place and then we ruin everything. Yes.
So a little bit further back to promise theory. The way I understand, the way I understand it is, it's pretty much a well-designed interface, I guess, between teams. I work on a platform team, and one of the issues I always have is how wide the interface should be. I get tons of various different edge cases, and I want to have that agreement where they request a hidden best needed, and then I bring it back, but then they'll be, well, they want it with sprinkles and then cream, and it gets excessive to the point where I don't know when I try to build a good platform how wide that promise should be or that interface should be before it gets too wide or too kind of haywire. Wondering if you have any approaches on how you tackle that.
I think in Lunar we are lucky that the landscape we have is very the same. I mean, it's basically Go services, everything. The ones with the biggest problem of having just one plan is actually the platform team. Because we don't build our own software that we run. We don't build Prometheus, someone else did. Right? Jaeger, have you seen the YAML file? That's insane, right? I mean, there was one of the services, I don't remember which one, but kubectl couldn't handle it. It was too big. It's like nuts. So instead of, but they do provide a Helm chart sometimes. And that's why we started using Helm behind the scenes, so we can just abstract it away. So we can define what's important to us, and it'll do the magic behind the scenes. But our developers don't need to know anything about Kubernetes or anything. There's one there.
So from a platform perspective, have you noticed any negative side effects of abstracting so much knowledge away from developers?
I would say no. I mean, they can opt out. They're always welcome to come and ask us. They can even make a pull request to the plan and say, hey, we would love to be able to define this in shuttle so that this is slightly different. And then we'll take a look at it.
So myself, I started as a software developer that didn't know much about infrastructure at all. And as I got more experience, I moved closer and closer to the platform side and noticed that there were, like, before I was thinking a lot in ways of how I could solve problems by coding, whereas now I might think about, okay, I can solve them by both writing some code, but also combining it with some sort of infrastructure tool, which I think maybe is missing when you abstract so much away from it. So I was kind of wondering if
I think
teams
it
sort of
depends
lack-
on the responsibility of a team. So
Okay.
streamlined teams, I mean, I talked to a person who said, hey, you should just do this, to developers, say they should do this yourself. And I told him, and they agreed when I came home, they would chop my head off if I did that. They really don't want to do these things. They want to solve their problem. They don't care if it's called an ingress or a route or a stanza or whatever. They really don't care. It doesn't give them any value. But of course, we need a plan that give them what they need, and it just becomes like using AWS. When you order a VM at Amazon, do you know what's going on behind the scenes? Do you want to? Do you need to? I don't care. Yeah. Are we overtime?
No, we can talk about that part. I think there's definitely some benefit in developer knowing it,
Yeah.
especially where platform team doesn't know application logic 100%.
Yeah.
So that's something you can utilize.
Yeah.
Or take that later.
We have had internal courses in Docker and Kubernetes just to make developers aware of what's happening. Yes. Oh, we need a. Okay. Super.
I just wanted to add that if you have this abstraction layer, then yeah, developers usually love that they don't have to think about it if you deliver.
Yes.
So to make this work, you need to actually, as operations, have a service that delivers
Yes.
and can be communicated with if there's something that doesn't work.
Yeah.
The minute you stop delivering there, the rest will break because then developers will want to do their own stuff.
Yeah. They need to trust it.
Yeah, exactly. So
And
that's
the same with
that's the thing that
AWS.
makes it work, makes
Yeah.
it break.
Yeah. You need to be slightly awesome.
That's the one from anonymous.
I'm getting old. I need to.
Do you fix the incident in life? If yes, how? Okay, how to face?
Or start change from.
Yeah.
Dev.
From dev.
Okay. Don't know if I understand correctly, but so it's faster for us to make a new release and fix the problem that way than to go in and do something else. And we don't want to do anything else. So we have 230 releases to production per week. And the amount of times we do a rollback is 2%. So in a week, 2 releases are rolled back. That doesn't mean that we don't have more errors. It's just that the other times we roll forward.
That depends on the developing team being there. If operations has the 24/7 watch, then they cannot fix the code in the team's products. So then the only option they have is then to roll back if it breaks during the night and the team isn't there. So it depends on who's available.
Yeah, I get. Yeah, I mean, and what the problem is.
Yeah, of course. If the problem is you can fix outside and you have testing works there. So it's my side that's broken. But if it's the team's product, then you can't fix it if you're the one on operations and then you need to roll back or figure out what changed because obviously something changed.
Yeah. So in ham CTL, you can see ham CTL rollback, and it'll do it automatically for you. So it is quite fast. But in most cases, developers just fix the problem and release again. We have 2 developers here from Lunar. And yes, so if it's a problem that they cannot fix, they are of course depending on us. But I would say that's rare that there's difference from dev to production. It's pretty much the same. So if they don't test enough in dev, then I would say it's not our problem.